Good software architecture is not just about what a system does, it is about how cleanly it is divided up. In this video, we explore cohesion, one of the two core principles of modular design, and we will see why keeping related things together is one of the most powerful ideas in building maintainable systems. Imagine a single class or service that handles user authentication, sends welcome emails, calculates invoices, and generates monthly reports. Every time you need to change the billing logic, you open the same file that also contains email templates. These responsibilities have nothing to do with each other, yet they are tangled together. The result is fragile, confusing code that is painful to change and nearly impossible to test in isolation. Think about a well-run professional kitchen. The grill station has tongs, grill pans, and marinades. The pastry station has piping bags, flour, and timers. Nobody stores cake batter next to the steak knives. Each station is highly focused on one kind of work, and because of that focus, every chef knows exactly where to go and what to expect. That focus is what cohesion means in software. Here is the structural idea made concrete. On the top, we have one large module with 4 unrelated responsibilities crammed together, that is low cohesion. On the bottom, we have refactored those responsibilities into 3 separate focus modules, one for authentication, one for billing, and one for notifications. Each module now owns a single well-defined slice of the system. The responsibilities inside each one genuinely belong together. Watch what happens when a requirement changes in a cohesive design. A product team asks for a new invoice format. The developer opens the billing module, and only the billing module. The change is scoped entirely to billing logic. Authentication and notifications are not touched and do not need to be retested. The billing module can be deployed independently. That speed and safety is the direct consequence of high cohesion. Changes stay small and contained. High cohesion has real costs up front. You have to think carefully about where the boundaries belong before you write code, but the long-term gains are significant. Modules are easy to name, easy to test, and easy to change safely. Low cohesion feels faster in the moment because you just keep adding to an existing module, but that debt compounds quickly. The only genuine advantage of low cohesion is initial speed, and that advantage disappears the first time you need to maintain the code. The most practical test for cohesion is the naming test. If you cannot give a module a single clear name without using the word, and it is doing too many things. Beyond naming, group things by the reason they change together. This is the idea Robert Martin calls the single responsibility principle. And remember that cohesion does not exist in isolation. It pairs directly with loose coupling. The goal is modules that are tightly focused inside and loosely connected to the outside world. Cohesion is about focus. A highly cohesive module has one clear purpose, and everything inside it serves that purpose. When cohesion breaks down, the system becomes fragile and hard to reason about. Paired with loose coupling, high cohesion gives you modules you can understand, test, and change independently, and that is the foundation of every well-designed system you will ever build or work on.